This is AP Calculus Pretest 9 solutions. Let's jump right in. So again, girls, you're going to score it, but for now we're doing the correct solutions on your new pretest. So we're looking for W prime of 12. I'm going to start with blue here. W prime of 12.
So we're not scoring it right now?
You're going to score it after you do the solutions.
Okay.
After you do the solutions for A, I'm going to score A. All right.
So we're taking notes right now, basically.
Yes. Notes. All right, so this is going to be approximately equal to, note that we don't have 12, so we have to use 15 and 20 to approximate it. We're going to find the slope of the secant line here. Carly, are you okay? All right, so we're going to say that this is going to be W of 20 minus W of 15. The y-coordinates divided by the x-coordinates, 20 minus 15. Again, this is the slope of the secant. This is just a formula that you need to memorize. We chose 15 and 20 because those are on either side of 12. All right, 20 corresponds to 71, 71.0. 15 is 67.9, so this is going to be subtracting 67.
No, isn't it 15 and 9?
Oh, yeah.
I don't know what I'm doing, but yes. Yeah, that is a point.
Yeah, definitely.
So I should be 9 and 15. There we go. W of 15 minus W of 9 all over 15 minus 9.
Wait, is that a point for Rosalie or me?
Well, who got it first?
Why not both?
Well, we both said it.
Okay, for sure. I'll do both. 67.9 minus 61.8. All of that divided by 67.9 minus 61.8. Wait, that's...
15 minus
I don't know what's going on. I must have not got much sleep. 15 minus 9. I'm just going to leave that as 6. So is that 6.1? Can I at least do some math right?
Yeah.
And if you did use your calculator, you could have left it at 6.1 over 6, but that is 1.017. And we need to have units because it said using correct units. So that's degrees Fahrenheit per minute. All right, so I'm not going to score it yet because we're not done. We need to interpret the meaning of your answer or within the context. So what does this mean?
Oh, wait, just
W prime of 12. This thing is talking about the rate of change. So this is the rate of change. The rate of change. And then what are our rate of change of the water temperature, because we're talking about temperature of the water in a tub, of the water temperature. All right, what are our units? So if it's the rate of change, then it should be degrees Fahrenheit per minute. So in degrees Fahrenheit per minute. And then from where to where? From, oh, it's not from where to where, it's just at a certain time, right? Because we don't have an integral. It's just talking about at time equals 12. So the time context is at time, or I can just say t equals 12.
Wait, do we need to say that it's like an estimation of it, or does it not?
You can say an estimation, that's fine too. But as long as you have it's a rate of change,
Okay.
then you're good. Or something along that lines. All right, this is the point where you score your own pretest, because it was for homework last night. It's going to be out of 2 points. One of those points is going to come from part B, though. So the first point, did you get 6.1 out of 6 or 1.017? That's plus 1. If you use units correctly okay, so if you have, I'll do it like this. If you have rate of change, we'll do plus 1 as well.
After you put 15 and 20, it's just doing that screwed up.
Wait, I said instantaneous rate. I don't know what.
Instantaneous rate is also fine,
Oh, thank God.
as long as you have the word rate. Instantaneous rate at time equals 12. All right, back to go into notes. Part B. So,
Wait, Mr. Sinosa, can we just like score it as you score?
yes.
So we, okay.
So for part B, we need to evaluate this thing using the table. So integral between 0 and 20 of W prime of t dt. So that's going to be, so here we have the derivative W prime, and we're taking the integral. Integral and the derivative cancel each other out. That's a fundamental rule of calculus, fundamental theorem of calculus rather. So this is going to be W of 20 minus W of 0. And that should be W of 20, what is that? That's 71.0, 71.0. And that's going to be subtracting W of 0, which is 55.0, 55.0. And I don't even need a calculator, even though we have a calculator for this problem, and that is 16.
I did not do
I didn't even solve. I'm so dumb.
that. Yes.
So this is directly from our notes. If you take the integral of the derivative, this is what pops out. All right, so moving on to the second part of the problem, interpret this. So 0 to 20, the integral of w prime of t dt, what is that? That is the total change.
Okay, I put the average rate of change.
Nope, no point. Average rate would be 1 out of 20, but we don't have that. It's the total change. That's the main word. Total change in temperature
Mr. Snow, what if I said
of water.
in temperature? Because I just like thought about imposition, but I said imposition in temperature.
So read your entire explanation. That is
No,
the,
it sounds really cool.
read it on your paper. It is the,
I'll read it for you.
read your answer to me. I want to hear the entire
total
thing.
Change in position in degrees Fahrenheit from. Wait, it's
I'm
wrong.
no, it is wrong because it's not position. It's a temperature. I mean, if it was a position of the particle of the I don't know, the thermostat or something like that of the
I think
mercury.
The trick to getting these right is adding more words, like just for the position and the change.
Mr.
The
Snow,
position
I
in
put-
degrees.
You'll get the right.
You're
No.
changing the position of the
Because like if you're
degrees.
thinking about the graph, the position does change as the degrees go up. So I feel like it does make sense.
Yeah.
I'm going to be strict and say no. Make sure you have it better for the test.
Wait.
I put change in temperature, but not of water.
That's fine.
Do you
Wait,
think,
wait.
can I read my answer to you?
Sure.
The thing means change in degrees Fahrenheit from 0 to 20 minutes. Is that? I didn't say the total change.
You said just the change?
Yeah.
I think that's fine because you have the change.
What the heck? I say total change and I get 0 points.
I'll give you the point, Carly.
Thank you.
Yeah, total change really is the key.
Wait, do we have to have the times?
From t equals, you don't really need to have the time, but this is the formal answer that you should be expected to give. From t equals 0 to t equals 20. All right, so if you got 16 degrees Fahrenheit, that's 1 point. This is going to be out of 2 points. You're now going to your own question. And if you have total change, that word or change roughly in there, that is going to be +1. Sophia, I'm not going to give you the +1 unless you write total change on the test.
Okay, but I still get it.
I'll give it to you, sure. All right, good. On to the next question. Okay, so number 1, part C. All right, now we're doing the average temperature because average has that fraction out in front. So we need to approximate that using a left Riemann sum. So 1 over 20, okay, that's good. 1 over 20, why am I using red here? Should be using blue. 1 over 20 integral of, from 0 to 20 of Wt dt. We're using a left Riemann sum, so what does our left Riemann sum look like?
A gun.
It does look like a gun, I guess. It looks like that.
That's what I always think
That's
is
what I
that
think
the
of.
gun points
To the right.
Wait,
to
don't
the
say
right
It's
for
a
left, and then it's like opposite.
So we're using the leftmost point for left Riemann sum.
I just right here.
It's a distance of 4. This is a distance of 5. This is a distance of 6. This is a distance of 5. So we have that written down on our notes. And then we're using the leftmost point, so 4 is going to be multiplied by 5. 5 is going to be multiplied by 57.1. 6 is going to be multiplied by 61.8. Let's go ahead and do that. So,
Going too fast.
well, I'm going to write it down for us again. So 1 over 20 times the quantity of 4 times 55 plus 5 times 57.1 plus 6 times 61.8, and then finally plus 5 times 67.9. And because this is a calculator question, I'm not going to go through each of these. You just punch this in on your calculator. You should get 60.79. degrees Fahrenheit. You don't need to have units on this one. You don't lose points, but you do need 60.79. All right, that's only half of it. It also asks us, does this approximation overestimate or underestimate the average temperature? All right, it's a left Riemann sum, and is it increasing or decreasing? It looks like it is purely increasing. It is a strictly increasing function. And just knowing that, we know that's an underestimate.
So is it okay to say like my answer, or can we literally just say underestimate because W of t is strictly increasing?
You can say underestimate because WT
Mr. Sindel,
is, yes.
what if I got my number wrong, but then I said it's an underestimate because W of t is strictly increasing?
You get the point for the underestimate, but no point for this. And again, if you need the logic for this, I can do a quick little graph. So we have a function that is increasing. So these points are increasing. It's a left Riemann sum, so I use the point on the left for each of the heights. So compare this to the actual function. The actual function looks like this. It's an underestimate because there's some gaps here. That's why it's an underestimate. All right, so how to give yourself points. You give yourself 3 points for this one, out of 3. So you get 1 point if you did the Riemann sum setup. So all of this work right here is +1. You do need to show that work. If you have your final answer of 60.79, that's +1. And if you say underestimate and you have the reason strictly increasing, give yourself +1. All right, and then finally, part D. So now we're going beyond that 20. So on the table, we only went up to 20, and now we're going beyond that to 25. So now we have a function. This is the rate of change, W prime now, instead of W, and it's given by this function. Based on that model, what is the temperature at time equals 25? This is a T start plus change equals end problem. So the time is 25, that's what we're looking for. What is the start? How do we find start?
Go back up to the stuff.
Yeah, it starts at 71 because that's where it ended off. So this is going to be 71.0. We're going to add the integral. The change is going to be integral of, and the quickest way to do this one is 0, or not 0, sorry. We start at 20 here, 20 to 25, and we just say W prime of t. We don't have to write out all this stuff. We don't need to get the point here. All right, so we need to punch this in on our calculator. Let me pull that up to show you how to do that. Open recent. All right, so I need to enter our equation 0.4 times square root of
For me, I was like about
t.
and then like
This is going to be times cosine of 0.06 t. Okay, so that's my y1. So I need to take the integral. So it's going to be math 9. It's the integral of my var is right, enter, of that variable with respect to x from 20 to 25. And I can add that to 71. I can just do it all at the same step, plus the initial condition. And I get 73.043.
Yeah, but I get 0 points.
73.043. All right. How to score yourself? So you get, this one is out of 2 points, you get a total of 9. So you get 1 point if you have this guy right here. So you need to have the limits 20 to 25. You have to have W prime of t, that's 1 point. And if you get 73.043, that's +1. And what should the units be here if we were being really exact? Unit should be degrees Fahrenheit. Perfect.
I always am confused. Does the degree sign go before or after the F?
It's always before.
I've been writing it after the whole
All right, so go to the very top of number 1 and give yourself, out of 9 points, how many did you get? Hold your hand up if you got more than 3 points. More than 4. More than 5. More than 6. More than 7. Perfect score?
Wait, how many was? Oh, yeah.
Okay, so you guys got 8. Nice. Very good. All right, so on to number 2.
Can I have one?
All right, so we're doing, yeah, this guy. So we're looking for R prime of 45. This thing is going to be approximated by the secant. Okay, let's choose the correct points this time. 45 is between 40 and 50. I'm pretty sure of that. So now we have r of 50 minus r of 40. All that divided by 50 minus 40. 50 minus 40. All right. 50 minus, and 50 corresponds to 55. And that's going to be 40 all divided by 10. That's going to be 15 over 10. And you can leave it as 15 over 10, or you can say 1.5. Either of these will work.
I'm an idiot. I said that
We're
55
saying
minus,
that.
but like I said it was 5.
Uh,
And, like I got it wrong. Because of that.
Yeah. So indicate units of measure. So our units here. So we're taking all of this stuff. This is going to be gallons per minute, or gallons per minute squared. Okay. So this is actually the one where you have to have the units correct in both A and no. Sorry, that's number 3. I'm thinking way too far ahead. How to score number 1? If you have this general quotient right here, give yourself +1. And if you have 1.5 or 15 over 10, either of these, give yourself +1.
Wait, Mr. Sindel,
Yes.
could you just,
But if you're like Kaylin that did 15 over 10 equals 5, that actually is a subtraction point because you have simplified further and it is now incorrect. Yep, you do lose a point. That is exactly how AP graders do it as well.
Kel, this was your face. You were like,
Wait, Mr. Sindel, what
Yeah.
if I wrote 3 over 2, and what if I wrote gallons per minute instead of gallons per minute?
That's perfect.
You said 3 over 2?
Gallons per minute is the same thing as gallon per minute squared. All right, part B is going to be out of 2 points as well. Let's go ahead and write out our notes. So we need to do r double prime of 45.
Wait, so Mr. Sindel, I would actually get 0 on that because
No, you have
Did you do the fraction over here?
yeah,
That's 1 point.
but then I got minus.
Well, then you didn't get this point, so it's just 1 out of 2.
Oh.
It's all about the points that you can get. You never get subtract points. It's always plus points.
Oh, I thought yeah.
All right, so this guy's a little bit tricky.
Well, I thought you were saying
So it's talking about the rate is increasing. So we're talking about what here? Rate is already gallons per minute, so rate is RT. And if I'm talking about increasing or decreasing, I'm talking about, anyone have it?
CVs?
Concavity?
Nice.
In terms of R, I guess, to clarify, is it R, R prime, R double prime?
R prime. R.
R prime.
Okay.
If I'm looking for increasing, R prime of T now needs to be greater than 0.
Yeah. No idea.
Oh, yeah, I was super confused. I like tried to remember that.
Do you know what I did, Mr. Sindel? I was like, R double prime. Well, I just need to take, like, you know how the R prime of something formula is like, I don't know, like A over B minus
I do
all
not,
that
yeah.
stuff. I did R prime of 50 minus R prime of 40 over, like, 15 because that's,
I don't know.
Okay, I can come and take a look at it too. So if R prime of T is greater than 0, on a graph, what we're looking at, if we're looking at the graph of the derivative, is something that looks, I don't know, something like this, where it goes and it's positive. What happens for the double derivative? Well, the double derivative is the height of each point. So at the height of that point, well, I guess it wouldn't be right there. It would be out here at 45. We know that the slope is now, if we're doing the graph of the derivative, it should be looking like this. It's going from a negative to a positive, or something like that. So what is the value of R double prime? R double prime is going to be 0. That is the height.
I was going to write 0 because I was like, oh, okay, I'll just take the derivative of 3 over 2, and that's 0. Because, you know, it just goes away. And then I was like, that's too easy. So I didn't write anything. Oh!
So fastest, that's the key word here. If it's occurring fastest, then if I was looking at the normal graph, instead of looking at, this is the graph of f prime of t, if I was looking at the normal graph, it would look something like this. Maybe not like that. What's the best way to explain this one? So this one can be explained best by looking at a different type of graph of f prime. So if I'm looking at a graph of f prime and it's not linear, and it looks something like this, I'm looking for the highest point. The highest point is going to occur at a CV of the double derivative. It's like the possible CV. This is going all the way back to unit like 1 or something like that. It's a CV from the double derivative, and that's where you set the double derivative equal to 0. So the double derivative is equal to 0 at the fastest time.
Is there like an easier way to mathematically get that, like formula or something?
Well,
There's no formula because we don't have any equation. So you can't look at a graph. You just have to know that if it's increasing fastest, then the derivative graph will have this flattening off. It'll have a slope of 0 at that fastest time.
Mr. Sindel, could you just take your answer from A? Like, because you already found R prime, and you got 3 over 2, or 15 over 10. If you just took the derivative of that one, you would get 0.
So you have to be careful about that because you don't have the equation that generates R prime. If the equation, for example, was, I don't know, 1.5x squared or something like that, that doesn't actually work. But somehow you have an equation that spits out 1.5 when I plug in 45. But if I take the derivative again, I have this 2 that comes down in front. Then that doesn't work because you don't have the original equation. So that doesn't work, Sophia. Although you probably will get the points because you accidentally got it correct.
So you have to draw a graph?
You have to think of the graph in your head or think about what it means to increase fastest. Increase fastest means if I'm looking at the graph of f prime, you'll have some CV at time equals 45. Some slope equal to 0.
So I got. Wait, Mr. Snell, can you just look at what I did really quick? I don't even know how to explain it, but like.
I can come afterwards.
Okay.
All right, so we need this, and then we have to say the reasoning because max at t equals 45 will have a slope of 0 on graph of R prime.
Oh, so like, I think I get it. So it's because it's it's increasing fastest. So that means it has to be a CV. So because it's R prime, then you know that means height. The height has to be 0.
It's not quite correct because the height, it depends on what graph you're looking at in your head though. Because if you're looking at the graph of f prime, the height refers to f prime. We're looking for R double prime.
Oh, so then it would be slope?
So we're looking for slope. The slope here is 0. So therefore, this thing is equal to 0.
But either way, you know it's going to be equal to 0 because it's a CV.
Right, exactly, fastest.
So you can just know that.
That, yes.
Okay.
All right, so this one was 2 points. 1 if you got 0, 1 if you have an explanation. It is one of those harder review questions. All right, on to part C of number 2. This is still number 2 that we're working on. All right, we need to approximate this using a trapezoidal sum. So let me write out the beginning. 0 to 90 of RT dt is approximated by, so trapezoidal sum. Trapezoidal sum means that I'm using the distance between here and here, which is 30, and I'm taking the average of these two, which is going to be 25. I'm going to take the distance between here and here, which is 10, distance between here and here, 10, distance between here and here, 20, distance between here and here, 20, and I'm taking the average of each of these. 30 and 40, that turns to 35. 40 and 55, that's 47.5, 47.5. 55 and 65, that's 60, and 65 and 70, that's 67.5. So you need to know the average of each of the pairs, and then you need to multiply all those together. So for example, the first one I'm going to multiply 30 times 25, 10 times 35, and continue on. So this is going to be...
Was that a 60 or a 69?
This is a 60. Yeah, I see the P kind of looks like it extends it. So multiply those together, what do we get? So we get 30 times 25 plus 10 times 35 plus 10 times 47.5 plus 20 times 60 plus 20 times 67, oh, almost, 67.5. And we need to do this without a calculator. How do we do that? So 3 times 25, and then we'll add a 0. 3/4 makes 75 cents. Add the 0, 750. 10 times 35, you just move the decimal, so 350. 10 times 47.5, again, move the decimal, 475. 20 times 60 is 2 times 6, add the 2 zeros. 2 times 6 is 12, add the 2 zeros. And this one was a little bit harder. I'm going to do 2 times 67.5, which is 135, add the 0, 135, 0. All right, so adding all of those up, you should get 4,125.
Oh my god! I didn't write mental math.
Oh, thank the Lord.
Or more like scribbled math on the sides.
I know.
That's okay.
Look at mine.
All right, so if you did this setup where you just had these numbers being multiplied, not actually getting what they multiply to, that's plus 1 point for the setup, and plus 1 point if you got 4,125. That was out of 2 points.
Another trucker? Wouldn't it just be a regular
Mostly.
equal sign?
I keep doing approximately equal to because we're approximating the value. All right, and then for part D is going to be out of 3 points so that we can add to 9. Oh gosh, what's going on? All right, so part D. We're doing 0 to b of RT dt, and we need to explain that. What is the meaning of this thing? This is the, I should say, is the total amount of fuel in gallons from 0 to b minutes.
Can I read you my answer, Mr. Sindel?
Yes.
So I said, that means change of fuel consumption in gallons per minute from 0 to 5 minutes, or b minutes.
Yeah, you'll get a point for it.
In terms of what?
Yep.
Like it means the total number of gallons consumed from t equals 0 to t equals 1.
Yeah, perfect. Yeah, something about it's the amount of fuel. The key word is the amount from 0 to b. Amount from 0 to b, those are the key things. If you did that, that's going to be a point, but I'm going to score this in a sec after I get through all of this and explain the meaning of this thing. So 1 over b integral from 0 to b of RT dt. That is the average value. Value of RT. And then our units in gallons per minute
No.
from 0 to b minutes.
If I didn't put gallons per minute,
So you're going to lose a point. All right, so 1 point if you say amount from 0 to b, that's plus 1. 1 point if you say average value from 0 to b.
What
That's-
if I said average fuel consumption? That's what I said.
Yeah, that's fine. And the last third point is if you got both of these. So if you got gallons and gallons per minute, that's plus 1. You had to get both of those to get this last point.
Wait, I said gallons per minute in the first one.
Then you don't get the point. So amount of fuel should be gallons.
One of them, you still don't get the
All right, how are we doing on time? We have time, okay. So moving on to number 3. Move to my notes for number 3. Oh gosh, where are my notes for number 3?
How many points was that?
Out of 9. Yeah, so score the top out of 9. Oh, I want to ask that question too. So this one was all out of 9. Raise your hand if you got 2 or more points. 2 or more. Raise your hand if you got 2 or more points on number 2. 3 or more points. Raise your hand. 4 or more. 5 or more.
Oh my god.
Wait,
6 or more.
wait, I got 6.
I got 6.
Nice. Okay.
Wait, Mr. Sino, I don't understand why the second one is gallons per minute, but the first one's just gallons.
Okay, yeah, I'll go through that right now. So if I'm talking about the amount of fuel is measured in gallons. Another way to memorize that is if I'm taking the integral of RT is gallons per minute. Integral will just go to gallons.
Oh, because then. Oh, wait.
Because you're not dividing by anything?
You're not dividing by anything, yeah. So this one is talking about,
Because then you divide by time still on that one, so it like brings you back to the root.
exactly, that's another way to think about this one. So this one is the same unit as gallons for this part. Remember, this is the same part that we just did in the first part, but now we're dividing by time, so it goes back to gallons per minute. But my favorite way to memorize this is if it's an average value always has the same units as whatever I'm taking the average of. I'm taking the average of RT, it'll have the same units as RT.
Okay.
And RT had units of gallons per minute. All right, number 3. Number 3 is also going to be out of 9 points. So part A is going to be out of 2 points. Let's go ahead and solve part A. Estimate acceleration at t equals 36. Show the computations that led to your answer, indicate units. So, acceleration at 36. How do we find that? Well, acceleration at 36, that's the same thing as v prime at 36. The derivative of velocity gives you acceleration. Bit of physics review, right? All right, so in order to find the average acceleration, what we're going to do is we're going to take the integral of, well, you don't really need to show the work, but it's the integral. Wait, no, it's not. I don't know what I'm saying. I'm sorry. V prime, we need to find the slope at 36. Slope at 36 was estimated by these 2 points. We're using the secant line, so this is going to be approximated by V of 40 minus V of 32. All this divided by 40 minus 32. All right. V of 40, that's 7, minus V of 32, that's negative 4. There's a double negative here. All divided by 8. 7 minus minus 4, negatives kiss, make it positive, and that's going to be equal to, all these should be approximately equal to 11 over 8. Just leave it as a fraction, 11 over 8 meters per second squared. Why is it per second squared? Because it's being divided by time, so it's meters per second per second.
What if I wrote meters per second per second?
That's fine. Yeah. All right, so how to score yourself? We're going to score ourselves after we finish grading B. B is also going to be out of 2 points. No, sorry, B is out of 3 points. Let's do B and then score both A and B together. Okay, we're explaining the meaning. So, integral between 20 and 40 of Vt dt. That means, or it is, the total change in position.
Oh my god, I'm so stupid.
Position.
God dang it.
So that's the key thing. It's total change in position. And our units are in meters.
I just wrote it was from 20 to 40, but I did 0 to 40.
From 20 to 40 seconds. So that's our meaning. And then we need to find that. And we're using a trapezoidal sum. All right, so we say integral between 20 and 40 of Vt dt. This is going to be approximated by trapezoidal sum means that I'm going to be doing difference here, which is 8, average here, which is 4.
Wait, Mr. Simone.
Oh, yep, I'm making a mistake, but yes.
Nope. Shut up.
I didn't say nope, I said ope.
No, how do you know, like, if it's a total change in position or if it's, like, the average or, like, you know what I mean?
Okay, so this, yeah, refer to your notes because I explicitly go through all 3 of the things that they can ask. But if it's just the regular integral, it's the total change. If it's the fraction, 1 divided by something, it's the average. Those are the general things. And there's a third one, too, to actually calculate, but that's the one I'm going to be doing right here, essentially.
So if it has a fraction in front, then that's the average?
Yep, if there's no fraction, it's total change.
Thank you.
Wait, so then if I said total change in distance, is that?
That's fine, yeah,
Oh.
because it's total change in meters. All right, so the reason I was wrong is because I have to go from 20 to 40. So I start here, here, and here. Difference between 20 and 25 is 5. Difference between 25 and 32 is 7, and then 8. And then I find the average of each of these. So average here is -9, average here is -6, average here, -4 plus 7 is 3, 3 divided by 2 is 1.5. All right, so I just need to multiply these together. 5 times -9, 5 times -9 plus 7 times -6 plus 8 times 1.5. Okay, and then on the outside, so 5 times -9, -45, 7 times -6, -42, 8 times 1.5 is 12. Do we know the shortcut for finding this? Finding 12 from 8 times 1.5?
No.
You just do 8 times 1 plus 8 times 0.5. 8 times 1 is 1, or is 8. 8 times a half is 4. 4 plus 8 is 12. You separate 1 and a half into two parts, 1 and a half. You multiply in, yeah, and then you add them at the very end.
Okay, that took me a while 'cause
Hold on.
All right, so if I add up negative 45 and negative 42, that's negative 87. Negative 87 plus 12, that makes a negative 75. So this thing is approximated by negative 75, and our units here are just meters.
So
can just leave it
now I
M.
need to take a trapezoid. Oh my god, I'm so slow.
Right at the same
All right, so this is going to be out of 3 points. So 1 point if you did the setup here, that's plus 1. If you said total change in position,
Extra.
what was that?
What if I did that plus 0 and 8?
No, you can't do 0 and 8 because it's from 20 to 40. So you're wrong there. No point.
At least you know that you know how to do it. It's not
Yeah,
like it's
you can
not-
get it correct on the test, which is the important
like,
part.
It's not like you mixed up the left and right. Like,
And if you got a negative 75, that's another plus 1. So that's out of 3 points. And then for part A, how do you score yourself? So you get 1 point if you got 11 out of 8. And if you did meters, so here and meters per second here, you have to have both of those correct. Then you can get that second point for part A. If you forgot meters in part B, you don't get the point. If you forgot meters per second in part A, you don't get the point.
it feels like they should put like the first one out of 1 point and then the second one out of 4 points so that they can read A first and score.
I can make that change just for us.
Okay.
yeah, because that's
Because like having to like go back and then can I read you my answer? I think I got it wrong.
Okay, go for it.
Okay, the thing means average meters per second.
Nope, it's not average.
Okay, I didn't think so. Dang it.
All right, on to part C. Part C is out of 2. Part D is out of 0. It's extra credit, but you can get up to 2 points. You can get a plus 2 if you got the extra credit. Again,
Oh my god.
you don't have extra credit on the AP test. It's just for this class because part D was a hard question.
Yeah, I have no idea.
Wait, so on the AP test, it'll just be.
It'll be a normal point, yeah. But you can miss it and still get a 5. That's why I'm treating this as extra credit. All right,
But the other hard ones we can't.
the other hard ones you should know how to do.
Okay.
All right, for part C, we need to use, oh yeah, so this one was pretty hard as well, but you should be able to kind of understand what's going on here. So change in direction, what is the definition of that, girls? What type of sign change? Yeah, V sign change, yeah.
Woo.
Equals V sign change. That's the main definition that we're going to be using for this problem. All right, let's look for the V sign change. Oh, sign change right there, sign change right there. So there's 2 times, at least 2 times. So we can say, we'll basically just say change in direction. Somewhere on this interval. You can go, so I'm going to do the official way of doing it, but I'll write the other way of doing it. So between 8 and 20, and between 32 and 40. So you can write them like that, or you can write them like this. Somewhere in the interval of 8 to 20, or somewhere in the interval of 32 to 40. Either of those intervals will be acceptable on the AP test, and in my class as well.
What if I said like 8 and 20?
That's fine too, yeah.
It's just, no, I just wrote, yes, there is a max at this and a min at that. At both of those points. I got the points right. Is that,
So did you say that it's a change in direction within those intervals?
well, you know, min and max is basically that idea. It goes from a positive to a negative or a negative.
So if I were an AP grader, I would say, okay, she has the first step, but she doesn't realize that if a min and a max occurs, that means that there's a change in direction. If you somehow link
But I
those two,
did because I answered to the question, is there a change in direction?
did you say change in direction anywhere in your own words? Then you can't get the points because you have to somehow link that with a maximum or a minimum.
Right,
No.
I know, you have to be explicit for the AP grader, so I'm not going to give you the point for that.
You don't know what I said?
Yes.
So, by MVT, the particle must cross the x-axis at least once when its velocity changes signs. So, like, does that make sense?
Say it one more time.
I said, it's by MVT, the particle must cross the x-axis at least once when its velocity changes.
You use MVT.
You're like whispering it.
So MVT
I
MVT
don't even.
talks about slope.
Wait, isn't there one where?
IVT, I think, is one you're thinking of.
Yeah, I think
What if I only said 8 and 20 and not 32 and 40?
I'm just gonna.
If you said 8 and 20 and what?
And not 32 and 40.
Yeah, so you have to have both those correct.
Hmm.
So I'll show you how to score this. If you have both these intervals, it's +1. And if you have an explanation, something like change in direction is a V sign change, that's another +1.
Mr. Sandal, I said because the velocity changes from positive from negative.
Yeah, exactly. That's a sign
There's a
change, yes.
velocity
That's your
sign.
explanation.
Oh, wait, what
Velocity
is
sign change,
sign
yes.
so. I don't know. I just totally guessed on this one.
But that's the whole idea of a min and a max is that the velocity changes.
Read your answer once again, Rosalie.
Yes, there
She
is
really wants
two. There is a max at 8 is less than t and t is less than 20, and a min at 32 is less than t and t is less than 40.
I just love your reason.
You just said max? Max of what? Max of V, max of position?
I just said min and max.
Yeah, you have to be more specific, sorry.
I do feel like it would be really.
All right, and finally, how to score part 3, or part D, I should say. So this one was extra credit. I'll talk about why. So we know that acceleration, AT, is equal to the derivative of velocity, so V prime of t. And we need, it says acceleration is positive, so that means both of these are both greater than 0. Okay, so let's start calculating using t start plus change.
I did start plus change.
So t is going to be 8. Start is going to be, our initial condition is 7. It says that over here. Initial condition is 7.
30?
And then the change is going to be the integral between
30.
0 and 8 of vt dt. Okay, we need that to be something, and we don't know what this is. So let's take a note down here. 0 to 8 vt dt. How do we find that? So it tells us that the derivative of velocity is always going up. It's always positive. And it also tells us that vt is 3 at time equals 0. So it starts with a velocity of 3, which means, and here's the key part to this question, girls, that the velocity must be greater than 3 everywhere in this interval, because it starts at 3 and the velocity is only increasing. So at every single time in this interval, the velocity must be greater than 3, because that was the initial condition. So the way that I say this is that this thing must be greater or equal to 8 times 3. 8 comes from 8 minus 0. 3 comes from the minimum velocity. I'm allowed to do times 3 here because that was the initial velocity, and I know I'm only going up from there.
Oh,
think
because
you
you
might have gotten
subtracted 8 by 0 times 3.
Mhm.
Oh.
8 times 3 is 24. So this thing is 24 plus 7. This thing needs to be greater or equal to 31. All right, and the question says, explain why the position of the particle must be greater than x equals 30. It's greater than 30 because it has to be greater than 31. 31 is strictly greater than 30, and there's your answer.
Wait, so like I actually kind of got it right because I said that if the particle is moving at a constant velocity, its position at t equals 8 would be x equals 24. So if its position is greater than 30, then that must mean it accelerated in the positive direction.
So you have the
So like I got the part about like 8 times 3 and stuff, but then like I didn't add the initial this stuff.
right, and because of how you score this one, you might not get any points for this. If you said this, just this right here, that's plus 1 point. And if you have something that says that the position at 8, which happened to be greater than 31, if you say the position at 8 is strictly greater than 30, and you have a decent explanation of how to get that position at 8, then you can give yourself plus 1. Are there questions on how to score this one?
Wait, so your explanation is just
My explanation is 24 has to be the minimum amount for this integral, and I added that integral plus 7 to get 31. Do you somehow get 31?
Okay.
If you have 31, then that is definitely an explanation for why the position at 8 is greater than 30. All right. No questions? Moving on to multiple choice. Wait, before we do that, how many points did you get? Add them up. It is, well, it's not going to be out of 9, I guess. This one is going to be out of 7.
Out of 7?
Yeah.
How come?
Because that last one was extra credit. All right. Raise your hand if you got 2 or more points. 3 or more points. 4 or more. 5 or more. 6 or more.
I got 6.
7? Perfect score? Perfect score?
Really?
Did you get more than 7?
Not a 7.
Nice. Good job.
Damn, Isabel!
Good job.
She was
Oh,
stuck.
we don't
All right.
have that even in the
We used to be
test.
a clapping class, but whatever.
All right, number 4.
Carly just told me all this.
There's a horizontal asymptote. That means E. What you're looking for is that the limit goes to x, goes to plus or minus infinity. This one is a minus infinity. This one is a plus infinity. So by default, it has to be between those two. And that has to be equal to 7. This one is equal to -7, so it can't be B. The answer is E.
So it has to be infinity if it's a horizontal asymptote.
Yep, as I go, because what you're thinking about is on the graph, you have a graph that looks like this. As I get closer and closer and closer in that direction to or to the left, I have this horizontal asymptote at 7. That's the pictorial version. Number 5. These are all out of 1 point. So number 5 is E. I believe. Let me check my notes to make sure I'm doing this correctly.
What'd you get?
I might have done something wrong. Let's check the math. So, taking the derivative, this is going to be quotient rule. Quotient rule is low d high minus high d low all over low low. All right, low is x squared plus 1. High is, our derivative of high is 1. I'm going to subtract high, which is x plus 3, times the derivative of low, which is 2x. All of this divided by low low. X squared minus 1 to the power of 2. All right, I could simplify, but I'm not. I'm going to go ahead and immediately plug in -2. That's the fastest
How
way.
did you get the 1 after the x squared plus 1?
The derivative of x plus 3 is just 1. All right, so I'm plugging in -2. -2 in here gives me a 4. 4 plus 1 is a 5. Minus, if I plug in a -2, I get 1 here, so that just turns into a 1. And if I plug in a -2 here, that's going to be a -4. So this whole thing turns into a -4. All that is going to be divided by, if I plug in a -2 here, -2 squared is a 4. 4 minus 1, or sorry, is that right? 4 minus 1 is
4 plus 1.
4 plus 1. That's the mistake. Thank you. That's an extra credit point. 4 plus 1 is 5. 5 squared is 25. It's 9 over 25. E.
You want to know what I did, Mr. Sindel?
All right, we have to go quick. Number 6. All right, we have this. This thing is going to be, this is just a strict definition. It is D. You need to know this definition.
Yay!
And finally, is this finally? No, we have 2 more. This is number 7, I think. Number 7. So this is a min here. This is a max here. This is a min here. So there's 1 min, 2 maxes. 1 max, 2 mins. Correct answer is A.
Yay!
And finally, number 8. Total distance. We do these shapes. This is going to be 2 by 3, which is 6. Half of that is 3.
What'd you get?
Same shape over here, 3. This is a 6. This is a -1 down here. But it's asking for total distance, so this is going to be a positive 1 now.
Oh,
This is the absolute value of velocity of t, total distance. So it's 3 plus 6 plus 3 plus 1. You should get 11.
What?
No, 13.
I
Oh.
was like, hold
Sorry.
on. I was like, what did you add wrong?
I added wrong. All right, score yourself at the very top. Before you leave, you need the fix-up sheet,
And our test is tomorrow.
Wait, so
and your test is tomorrow.
is it maximum when it goes from positive to negative? Like, what's the definition of maximum?
Maximum is where it goes from a positive to a negative.